here's an experiment. Let's say there's a 4-question multiple choice quiz, and you have to randomly guess the answers. Maybe you didn't actually read, or didn't get a chance to study. So let's say you have to guess. So it's a 4-question quiz, and your teacher was feeling gracious, so they only gave you choices A, B, and C instead of A, B, C, D or A, B, C, D, E, right? So what's the probability that you're going to guess this first one right? How many of these are the right answer? 1 out of 3. That would be if you got it correct, right? What's the probability that you get it wrong? 2 out of 3, because 2 of the choices are wrong, and then you have 3 choices. So this says construct a tree diagram. Let C be the correct answer, let W be the wrong answer, and X, we're going to figure out X, is the number of correct answers. Okay? So we're actually going to make the tree diagram. You have this blank slide. You have the whole rest of the page, and this is for a reason. I get that you're getting ready to go, oh my gosh, Ms. Harrell, seriously. But here's the deal. When you have to, do something yourself, you're more likely to remember it. And it gives you an appreciation for the formula. Whereas if I just go, oh yeah, here's how you do it, here's the formula. Where did it come from? Well, it came from these mathematicians who didn't have formulas. So they just sat and thought and worked and figured out how to figure this stuff out. You know what I mean? So on the first one, we're either going to get it correct, right? Or notice I'm skipping a lot of space. We're either going to get it wrong. So what's the probability that I guess it correct? Y'all just told me. 1/3, right? What's the probability that I get it wrong? 2/3, because you have choices A, B, and C, and only one of them's right. The other 2 are wrong, right? Okay, so this is for my first question on the quiz. So on the second question, if I got it correct, then I might get it correct again, or I might get it wrong, right? But what if I missed it the first time? Well, then I'm either going to get it correct or I'm going to get it wrong. What's the probability I get the second one correct? Still just 1/3. Thank you. Right? 1 out of 3. And the probability we get it wrong is still 2 out of 3 because you have 3 choices. All right, so this was my second question. Well, don't I have to do it again? Yeah, you have 4 questions on this quiz. So the third question, I'm either going to get it right or I'm going to get it wrong. But I might have got it correct and then wrong, so I'm either going to get it right or I'm going to get it wrong. And the probability I get it right is 1/3. The probability I get it wrong is 2/3, right? You don't have to keep writing the 1/3 and 2/3 if you're good with it. Everybody good with it? Okay, so I have to go down here and do the same thing, which would be that I get it correct or I get it wrong, but I might have got it wrong and then wrong, but maybe I get it correct the next time or wrong. Whew, we've done 3 of them. How many questions was on this quiz? 4. All right, so one more time. I either get it correct or wrong, correct or wrong, correct or wrong, correct or wrong. Same thing down here. Correct or wrong, correct or wrong, correct or wrong, correct or wrong. All right, so what are your options? Follow your branches. Correct, 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 correct. C, 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 C. Then correct, 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 wrong. C, 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 W, right? Then correct, correct, wrong, correct. Then correct, correct, wrong, wrong. And I've done the first 4 options, right? So now I have to do correct, wrong, correct, 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 wrong, correct, wrong, right? Or maybe correct, wrong, wrong, correct, correct, wrong, wrong, wrong. Do you see that you have 1, 2, 3, 4, 5, 6, 7, 8 just up here? Do you see them? I don't know why I started writing those W's so big. Good glory. Let me try that again. Okay. But that's assuming we got the first question correct, right? Well, now you have if you got the first one wrong. So you have wrong, correct, 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 wrong, correct, correct, wrong. So I just followed the top branch and got those two. So now wrong, correct, wrong, correct, wrong, correct, wrong, 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 correct, wrong, wrong. Yep. Wrong, wrong, correct, correct, wrong, wrong, correct, wrong. I just followed this branch. So now wrong, 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 correct, wrong, 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 wrong. Whew! We did it, right? So how many did I get correct in this first one? All 4, right? How many did I get correct on this one? 3, then 3, then 2, then 3, then 2, then 2, then 1, right? Then I have 3 correct, 2 correct, 2 correct, 1 correct, 2 correct, 1 correct, 1 correct, none correct, right? So how do we figure out the actual probability? Well, do you know the probability of getting it correct? Wouldn't that be the C? So this is equivalent to what? We get it right, and, so multiply, we get the second one right, and what? Do you ever have those moments where you don't write what you think you wrote? 1/3 and, so multiply, 1/3 and 1/3 and 1/3, right? Correct, and correct, and correct, and correct. So the other way to write this is quantity 1/3 to the 4th power, which is 1 out of, what's 3 to the 4th power? 3 cubed is 27, so 27 times 3 is 81. So do you see? You have 81 options for how this quiz is going to go, right? And one of those 81, you actually get all 4 correct. Wow. It's pretty terrible, isn't it? And that's if it's a third, meaning you only have choices A through C. What if you had choices A through D? That'd be a 4th times a 4th times a 4th times a 4th. Wow, even smaller, right? Okay, so 3 correct would be 1/3 times 1/3 times 1/3 times, you got a wrong one. What's your probability of getting it wrong? 2/3. So this is going to be 2 out of 81, right? So you see, if you were rewriting it, I could have rewritten it 1/3 to the 3rd power and then 2/3 to the 1st power. You see that? I just didn't, but do you see? Okay. This is again 3 and 3, so I'm not going to do it again, but I get 2 out of 81. This is 2 of them are correct. So I'm going to do 1/3 times 1/3 times 2/3 times 2/3, and I get what? 4 out of 81. Yep. This is 3 correct, so that's 2 out of 81. This is 2 correct, so that's, let me go over here, I'm running out of room. 4 out of 81. This is 2 correct, so 4 out of 81. This is 1 correct, so I need to do this one, don't I? 1/3 times 2/3 times 2/3 times 2/3, which gives me 8 out of 81. Yep. 3 correct is 2 out of 81. 2 correct is 4 out of 81. 1 correct is 8 out of 81, 4 out of 81, 8 out of 81, and 1 out of 81, so, I mean 1 right, which is 8 out of 81. Okay, how about none right? 2/3 times 2/3 times 2/3 times 2/3, right? 16 out of 81. Whew. It's probably not good to have to guess on all 4 questions, is it? Because the probability of you getting it wrong is higher than the probability of you getting it right. Correct? Isn't that right? Do you have any questions on this tree diagram? Now, do you want to have to make a tree diagram every time you want to figure out the probability of you getting an answer right or wrong? No, because think about that. What if it was a 10-question quiz? Holy moly, how many branches would you have? You know what I mean? So that's where I'm going with it. Let me skip ahead. It's called the binomial probability function. And you have this, which this is the same as n choose x. Instead of a k, it's an x. Right? That's why I kept emphasizing what that means. Times p to the x, where x is 0, 1, 2, all the way up to n, times q to the n minus x. Well, where in the world did this formula come from? Well, let me show you. That's why I just made you do all this work. What are your options for how many you got correct? We wrote them all right here. You get 4 right, 3 right, 2 right, 1 right, or 0 right. Okay, so we can write our binomial probability distribution for x. We'll have x, and then we'll have p of x. The probability of x being correct. Remember on the first slide it says x equals the number of correct problems, right? So p of x. So we have the option 0 right, 1 right, 2 right, 3 are right, or all 4 were right, right? Okay, how many times did we get 1 right? I mean none right, excuse me, 0 right. Once, times, and then what was our probability? Well, if they're all wrong, it was what? Look, 16 out of 81. So we would just get 16 out of 81. Now, I want to explain where that comes from though, okay? So it occurred one time. I'm going to write this over here. It occurred one time, so that's times. And then in a bracket, I'm going to put how many I got correct, how many I got wrong, the probability. So the probability it's correct, well, if they're all wrong, none are correct, would be 1/3 to the 0. And then times, the probability it's wrong was 2 out of 3, right? And how many of them are wrong if none are correct? If none are correct, how many are wrong? 4 of them. And 2/3 to the 4th power is 16 over 81. I'm trying to introduce you to the binomial probability function, okay? And this is where it comes from. So how many times did we get 1 right? Go back. How many times did we get 1 right? 1, 2, 3, 4. 4 times, right? So we have 4 times. And then what was the probability when we got it right? 8 out of 81, right? Yes? Wasn't it? Okay. So what is 4 times 8? It's 32, right? So the probability that you get 1 right is 32 out of 8. But I want you to see it written this way. 4 times we got 1 right. We got 1 right, so that's the probability it's correct was 1, and that occurred, and we got 1 right, so that's a 1, times, if 1 is right, then how many are wrong? You know what I'm saying? It's a probability that 1 is right, how many are wrong? 3, right? So 1/3 to the 1st power is 1/3 times 2 cubed, which is 8, 3 cubed, which is 27. Then when you multiply, you get 8 over 81, which isn't that what I wrote? Do you see what I'm trying to do so that you don't have to make that big tree diagram every time? I'm trying to explain where this comes from so that you'll go, oh, thank goodness I get to use that instead of make a tree diagram. All right, how many times do we get 2 right? Go back and count. 6 times, yep. Times, what's the probability, though, when you get 2 right? 4 out of 81, right? Okay, and 6 times 4 is 24, so 24 out of 81. All right, so 6 times, and then you have 2 right, so that would be 1/3 squared, because the probability of getting it correct is 1/3, right? You want to know how many, so that would be, you have 2 correct. So then if 2 are correct, how many are wrong? 2. So this would be squared. Do you see what I'm doing? If 2 are correct, 2 are wrong. If 1 is correct, 3 are wrong. If none are correct, 4 are wrong. That's where the exponent's coming from, okay? And again, if you did all the work, it would be 1/9, because you square this, times 4/9, right? Which gives me 4 out of 81, okay? All right, let's do this one. How many times was 3 correct? 4. Yep. And the probability of 3 being correct? 2 out of 81, which gives me 8 out of 81. So over here I would write 4 times. The probability that 3 are correct would be 1/3 cubed, right? Times. If 3 are correct, then 1 is wrong, right? So that would be a 1. Okay? And lastly, how many times did we get all 4 correct? Once. And the probability of that happening was 1 out of 81. I remember saying that to you, right? So that would be 1 times quantity, 1/3 to the 4th power, because they're all correct, which means 2/3 to the what power? 0. Anything to the 0 is just what? 1. Yes, thank you. If you said that already, I'm sorry. It's weird when I have these things on. You know, I can't hear. Okay. Whew. Do you want to make a tree diagram every time? I definitely don't. Because what if you have way more options, right? Like A, B, C, D, and E. Binomial means it's either right or wrong, or a success or a failure. So you're always going to have, you know, 2 outcomes, either success or failure. But what if you have way more choice, you know what I mean? So that changes your probability. Instead of 1 out of 3 to get it right, it might be 1 out of 7 or something. You know what I'm saying? Okay. How many of the 4 questions are you likely to get correct? Well, which one occurred the most? 2 occurred the most that you got correct? Time out. Did we do something wrong? Which one occurs the most? 1, 2, 3. I had 1 correct occurred more. Is that true though? 1, 2, 3. Oh, you have to look at your probabilities out here. You know what I'm saying? Which one has the highest probability? The 1, yeah. So 1 answer correct. Right? Because that had a probability of 32 out of 81, didn't it? I just almost got myself confused. Because I was like, wait, 2 occurs more than 1 occurs. But if you look at the probabilities, this was higher. And that's about 0.395. All right, how likely are you to get more than half correct? That would be 3 or more, right? So 3 correct was a probability of 8 out of 81, right? 4 correct was a probability of 1 out of 81. I'm looking right at my chart that we just made, aren't you? So to get 3 right, that's 8 out of 81. To get 1 right, that's, 4 right, that's 1 out of 81, which gives me 9 out of 81, which reduces to 1/9. And remember what I taught you? Anything divided by 9 is just that number being repeated, remember? So 0.111111. Okay. What is the probability that you selected the wrong answers for all 4 questions? That means all 4 are wrong. So none right. What was that probability? 16 out of 81, which is about 0.198. All right, if the entire class answers by guessing, what do you think the class average number of correct answers will be? Well, what's the probability that you're right? I mean, what, if you're guessing on one question, the probability you're right versus wrong. Probability you're right is 1/3. Yep. So 1/3 of, and how many questions were there? 4. 1/3 of 4 is just 4/3. Because you multiply. I guess I should show you that step. Sorry, I got ahead of myself. 1/3 of 4 means 1/3 times 4, which is 4/3, or just 1 1/3. So about 1.33333 is going to be the class average for number of correct problems. Would you assume it's going to be something between 1 and 2? Yeah, because look at the probabilities. 16 out of 81 for none right, 32 out of 81 for 1 right, 2 out of 81, 24 out of 81, I mean, for 2 right, and then 8 out of 81. So see right there, the probability is higher to get 1 right than 2, but it's going to be a little bit bigger than 1. So does that make sense? Okay. So the binomial probability experiment will stop here. I didn't actually give you any homework on the binomial experiment because it kind of can make your brain hurt a little bit, right? So you do need to email me your project idea, okay? I do need that. So make sure you work as a team. Read those guidelines. Make sure you follow them, all right? You already have your homework, and it's due on Tuesday, okay? Good luck with your articles. I love you. Have a great day.